So in this video we're going to talk about solving systems of equations by elimination. And so the steps are over here on the right in blue. We can run through these real quick, but it'll make a lot more sense once we do a couple problems together. So our first step is we're going to multiply one or both of the equations. So one of the variables has the same coefficient or opposite coefficient. So what I mean by that is maybe we'll have two equations where the first one has like a 2x and the other one has a 2x plus, some stuff, and those are the same coefficients. Or you might have something where it's 2x and negative 2x plus, some stuff. So then they're opposite coefficients. So what I mean is they're the same coefficient but just opposite signs. Then we're going to add or subtract the two equations together to eliminate one of those variables. Step 3, solve for the remaining variable. And then step 4, plug it into one of the original equations and solve for that second variable. So let's take a look at what I'm talking about here with this first example. We've got 4 examples we're going to run through. And in our first example, if you notice, the negative 2x and positive 2x are the same, just one's positive and one's negative. So what we can do then with these two equations, we got step 1 is already done. Now we're going to do step 2, and we're going to add these two equations together. And when we do that, the two x's cancel out. And if we do negative y plus negative 3y, we have negative 4y. And then negative 4 plus 12 is 8. So then I'm going to divide by negative 4 on both sides. And I get y equals negative 2. So if we're looking at our steps, I can zoom out here. We added the two equations together, and then we solved for that remaining variable. Now step 4 is plug it into one of the original equations and solve for the second variable. So now we're going to figure out what x is by plugging negative 2 in for y. So I'm going to choose the original first equation. You could use the second equation. That's totally fine if you did that. And I'm going to rewrite it here. It's negative 2x minus, and then we already know what y is. So I'm going to put negative 2 in for y. That's where what we just solved for. So we've got negative 2x minus negative 2 is plus 2 equals negative 4. And then I'm going to subtract 2 from both sides. I've got negative 2x equals negative 6. And then divide by negative 2, and I get x equals 3. So if you want to check, you could try plugging them both into the second equation. And let's see, 2 times x would be 2 times 3, which is 6, minus 3 times negative 2 would be negative 6. 6 minus negative 6 is indeed 12. So it does check out if you plug it into the other one. And that's one way to check it. So what this means is on the graph, these two equations, they're going to be graphed on the graph. And if we go over 3 in the x direction and down 2 in the y direction, that's where these two lines are going to cross. Now, they may not look exactly like this, but what it means is when you graph those two lines, the intersection of those two lines is going to be 3 comma negative 2. So when you get your answer, that is what it is. It's the intersection of those two lines on the graph. All right, let's look at example 2. So on this one, same first step. It says multiply so that they have the same coefficient for either x or y. And fortunately for this one, we have a 3x and a 3x. So what I can do is I can subtract these two equations because I want to eliminate the x's. That's why it's called elimination. So 3x minus 3x, those are canceled out. And then we have negative 2y minus 7y would give me negative 9y. And then 1 minus 64 would give me negative 63. So I can then divide by negative 9, and I get y equals 7. So just like the last one, I didn't have to multiply because there was already 3x and 3x. And then I subtracted the two equations together. Then I solved for y. And now I'm going to plug that in and solve for x. And so it doesn't matter which one you choose in terms of which equation you want to use. But I'm just going to use that top one. That one looks relatively easy to work with. We got 3x minus 2 times y, which is 7, equals 1. So 3x minus 14 equals 1. And if I want to get x by itself, I'm going to add 14 to both sides of the equal sign. And I get 3x equals 15. And then I'm going to divide by 3 on both sides, and I get x equals 5. So my final answer here is 5, 7. You could leave it as what we wrote down here, x is 5, y is 7, or you could write it as an ordered pair like I did there. And once again, if you plug it back in for x and y into the second equation, it will check out. All right, look at example 3. This one's going to be a little bit more tricky than the previous two. If you notice here, the x's are negative 3x and positive 7x, so those aren't going to cancel out. And the y's are 8y and 2y. Those aren't going to cancel out, so we cannot add or subtract these equations the way they are written right now. So we're going to have to do the first step, which is multiply one or both of those equations to get the y's to cancel out. Or the x's, I'm sorry. Kind of tipped my hand there. So if you notice, 8y and 2y, what I could do is I could multiply by something so those are the same. So what I'm going to do is I'm going to multiply this bottom one by negative 4. And the reason I chose negative 4 is because I want that 2y to turn into negative 8y, so when I add them together, now they're going to cancel out. So when I multiply by negative 4, I get negative 28x minus 8y equals negative 64. And then I'm just going to rewrite that top one right next to it. Negative 3x plus 8y equals 2. And now if I add these two equations together, let's see, I get negative 3x minus 28x is negative 31x. The y's cancel out. And then 2 plus negative 64 is going to be negative 62. And then I've got the y's are gone. Now I can solve for the x. I'm going to divide by negative 31 on both sides. And I get x equals positive 2. So I plugged it in. I got x, or I eliminated the y, and then I solved for x. And now I'm going to do the same. I'm going to, just like we did before, I'm going to pick one of these two original equations. Maybe I'll take the first one here, and I'm going to rewrite it where I know x is 2. So it would be negative 3 times 2 plus 8y equals 2. Negative 3 times 2 is negative 6 plus 8y equals 2. And then I'm going to solve for y, so I want to get rid of that plus negative 6. I'm going to add 6 to both sides. I get 8y equals 8. And then I'm going to divide by 8, and I get y equals 1. So our final answer for this is x is 2 and y is 1. That's where those two lines are going to cross on the graph. Okay, our final example, let's take a look at one where it's a little bit more tricky. If you notice, the x's aren't going to cancel out if we add them. The y's aren't going to cancel out. They'll get close. You'll get to negative 1y, but that's not what we want. We want the y's to cancel out. So what we're going to do is if the x's won't and the y's won't, and you can't just multiply one of them to cancel out the x or y, then we're going to multiply both equations to get an x or a y where they'll be the same coefficient. So the easy way to do that is I'm going to multiply the top by 7 and the bottom by 4. So I basically chose the x coefficient and multiplied by the other one. And you could do negative or positive. It doesn't really matter. That would just change if you're going to add or subtract it on the next step. And you could have chosen multiplying by 5 and 6 instead, and that would have eliminated the y's. So you have a lot of choices here. So when I do that, I get 7 times 4x is 28x. 7 times 5y is 35y. And 7 times 1 is 7. And now I'm going to distribute that 4 into everything here. 4 times negative 7x is negative 28x. 4 times negative 6y is negative 24y. And 4 times 12 is 48. So now that I did this, the x's will cancel out, so that's kind of nice. And then the y's, when we add those two together, we have 35 plus negative 24 is 11y. And then 7 plus 48 is 55. So now I'm going to divide by 11. I get y equals 5. That worked out kind of nicely. And then you can pick either of these two equations. I'm going to choose the top one because there's no negative, so it gives me less chance of making a mistake, but you could use the bottom one, it doesn't matter. And we have 4x plus 5y, which is 5, equals 1. So then I've got 4x plus 25 equals 1. I'm going to subtract 25 on both sides of the equal sign. I get 4x equals negative 24. Divide by 4, and I get x equals negative 6. So, where do these two lines cross on the graph? Negative 6, comma 5. Alright, so we saw one of pretty much every type of elimination example. Hopefully that helps with your solving by elimination.